Our Quarry Life project aims at answering the question that how to find the optimal reuse alternative for quarries. In Estonia, we have several possibilities to use in quarries. We can create a recreational land there or turn it into a water body. We can create a forest or meadow or use it as a arable land or create an urban development. Also, when there are some protected species present in the quarry, we should create a habitat for them. Our first step consists of decision tree, and we created the decision tree in cooperation with experts. And the second step is a comparison criteria model, which has 4 alternatives: forest, meadow, arable land, or recreational area, and also 12 comparison criteria. And we created the model in cooperation with stakeholders and also based on scientific literature, planning documents, and asking the preference of a landowner and local people. And we applied our decision process and the decision tree and comparison criteria model to 4 quarries in Estonia, and Mereäärne clay quarry, Aru-Lõuna and Tootsi-Lääne limestone quarries, and Ubja oil shale quarry. And all those quarries are located near the small city of Kunda. We asked questions from 93 stakeholders belonging to the main groups of stakeholders, like scientists in the field of mineral resources, representatives of Land Board and the State Forest Management Center, who are also the landowners of those sites, local municipalities, representatives of environmental NGOs, companies providing environmental analysis and consultations, ministries of environment and the Ministry of Economic Affairs and Communication, and also environmental board who gives out the excavation permits, and also mining companies. And most of the respondents had knowledge or also knowledge and experience in the field of quarry rehabilitation. And in cooperation with the stakeholders, we found the weights for comparison criteria. The most important were the preference of landowner and also maintenance costs, but also conformity with the local green corridors, preference of local municipality, aesthetic values were important to stakeholders. And for all this work, we made expert interviews for the decision tree. We had this stakeholder survey. We used the scientific literature to find values for each comparison criteria in case of each alternative, but also used planning documents and databases. And so firstly, to find an optimal reuse alternative for Aru-Lõuna, Tootsi-Lääne and Mereäärne quarries, we managed to use only the decision tree. And in those 3 quarries, the way down the decision tree was similar. Firstly, you have to apply for the extraction permit, and then we added one step to existing process based on legislation, that if there is any registered probable economic or probable potential economic reserves, that can't be excavated directly under those approved economic reserves that are going to be excavated based on this extraction permit. Then we should analyze if there is possibility to turn those underlying mineral resources also to proved economic reserves. Then we can use the land more sustainably, but also use the resources sustainably. But then we must choose the reuse alternative for the quarry also. If there are no intended purpose, as in those 3 quarries, based on planning documents, and also no demand for the quarry to be used for a real estate area, then we must look at the water table height after the reserve is exhausted. And if it's over 2 meters deep, then the only possible ways to create a water body there. And then we must excavate the uppermost layer or also the bottom layers. And if there is no protected species present in the quarry, then we can carry out the rehabilitation option that we chose before. In this case, it's creation of a water body. In case of Ubea oil shale quarry, the path down the decision tree is somewhat different. We also start from applying the extraction permit and checking also the reserves and analyzing if we can also exhaust the bottom layers. But then we will use multi-criteria decision analysis, this decision tree, to find the optimal reuse alternatives. Also in Ubea quarry there are no intended purpose or also demand for the quarry rehabilitation as a national defense, transportation or real estate land. And but water table after the height after the reserve is exhausted does not reach the surface, differently from 3 quarries before. So the groundwater depth is over 1 meter deep, and we accept the long-term continuous maintenance costs that are sometimes not considered acceptable. And in that case we can create the forest, meadow, arable land or recreational area in that Ubea quarry. But now we must choose which rehabilitation alternative is the most optimal. And we must identify the site-specific values for comparison criteria based on planning documents and asking preference of local landowner and the local municipality. And step 2 is the ranking of rehabilitation options with the decision matrix, which allows to identify the optimal rehabilitation option for the quarry. Now to the step 2. And we only need to change site-specific values in first the upper matrix, and this changes and calculates the results in the second matrix. And firstly we must add some or change some site-specific values for preferences of landowner and local people. And here you can see all the site-specific values are for that Ubea quarry. and the landowner and local people preferred the forest, but thought the meadow was the least suitable or least preferred, and local people thought that the arable land was least suitable. And also based on planning documents or databases, we saw that the forest was considered the most suitable based on planning documents, but also it was brought out that the forest supports the green corridors most, while there are no differences in case of other three alternatives. So adding those 4 site-specific values, we can see that the forest got the first highest rank, so it's the most optimal. And it has the highest weighted sum also. There are no not big differences with the meadow and recreational land, while the arable land was considered least preferable. So now we know that the forest is the most optimal reuse alternative also for the Ubia quarry. And if you want, you can also change the other values of this comparison criteria, but it should be based on some expert knowledge or scientific literature. So we now know the most suitable alternative. We have excavation permit, and we can carry out the excavation. If there are no protected species living in that area during the excavation, then we can apply the most optimal reuse option, which was forest. So now we know that the Mereäärne, Toolselane and Arulõuna quarries, it is most optimal to rehabilitate as water bodies, but for Ubia oil shale quarry, the most optimal reuse alternative is forest. These all rehabilitations are same that were chosen before for those 4 quarries, so the model supports the expert knowledge. This model can be used to introduce the quarry decision making to stakeholders, to local communities, so they can see that which criteria have been considered, that this is transparent, and they can also try out that they achieve the similar results. This model also can be easily modified and used in other countries and quarries. And if, for example, Heidelberg cement considers biodiversity with a higher weight, then this can also be added to the model. So have a nice try with the model and see what are the optimal reuse alternatives for your quarry.